Alrighty, as I said, we're going to do the class for your spring break on video, and you'll probably notice this is a little different classroom. I'm actually doing this on the Tuesday before test 3. I simply moved upstairs to a different classroom, so if I look the same as I did on Tuesday before our test, there's a reason, because I simply asked Mr. Belk to set up the equipment, and I moved up to, I think this is 307 or whatever. Okay, I'm not exactly sure where I'm going to try to do this. So let's see, it's about 2:30 when I'm starting this now. And I'm not going to go more than an hour, maybe not even that much. So we'll see, how far I get in that period of time. But your test ended with chapter 8, so we're going to start with chapter 9. Okay, let's go to the vocabulary as we usually do. And on page 285, you can see the term cognition. And this chapter is on cognition, language, creativity, and intelligence. Obviously, we've gone sort of in a logical sequence. We talked about the nervous system, we talked about sensation, we talked about perception, we talked about cognition, and now we're going to put it all together in terms of cognition, language, creativity, and intelligence. And you can see that the term cognition, the process of thinking or mentally processing information, images, concepts, words, rules, and symbols. And obviously thinking is a very, very important process for humans. This is what distinguishes us from many ways from other species. Now, one of the types of thinking that we probably share with most species is that we do create images. And you can see the definition on page 285. Most often a mental representation that has picture-like qualities and an icon. So, we can think in terms of pictures, and obviously other species probably, we can't get inside their head to, sort of see exactly how they think, but, we imagine that they produce mental pictures also, and this is the way they sort of understand the world. But this is not very economical, and this is why humans have developed the ability to use concepts. And you can see a concept is a generalized idea representing a category of related objects or events. Now we're going to look at the different types of concepts in a question coming up here. But for right now, I'd simply like for you to be aware of the definition and be able to match up the definition with the term. Now obviously once you get to concepts, it's important to have something to sort of represent the concept, and that's where we use language. Language is a symbolic way of representing concepts. So you can see the definition here on 285, words or symbols and rules for combining them that are used for thinking and communication. Now on page 289, you'll see the concept of semantics. Whenever we start using symbols or words, then those symbols or words have to have meaning. And that's what we mean by semantics, the study of the meanings in the words and in the languages that we use. So semantics, equate that term with meaning. Now obviously if you're going to use symbols or words, you have to use them in an order that makes sense and can be, let me close the door because there's another class. It has to be used in a way that sort of makes sense, that there is an order to it, and that's what we mean by grammar. Now obviously you don't have to look at the definition on page 291 to know what we mean by grammar, because you've been studying this throughout most of your schooling. A set of rules for combining language units into meaningful speech or writing. In English classes, our major component of English classes is to teach you the rules to using language in the way that we as a society feel that it should be used. Now obviously there are some people who don't learn the rules exactly the way most English professors and teachers would like for people to learn the rules. Also, something very interesting that's going on in terms of texting. Obviously, the rules that apply for texting are very different than the rules that you would see like in the Little Brown Handbook, as an example. But there have to be some rules. I mean, you can't sort of share meaning unless you sort of share an understanding of the rules, and that understanding of those rules is what we refer to as grammar. When we talk about problem solving, there's some things that we can do. Let's leave out mechanical solutions. Obviously, mechanical solutions is sort of like trial and error. Understanding is when we have a more global sort of appreciation for how to solve a problem. But I would like to include the term algorithms. I'd like to ask you to be familiar with the term algorithm. And some of you are already familiar with the term algorithm because you may have come across this in the math or computer science classes. And you can see on page 293 that an algorithm is a learned set of rules that always leads to the correct solution of a problem. Now the reason this is important, obviously this chapter is on thinking, it's on intelligence, and we realize more and more as we develop more sophisticated computers that our thinking in many ways is somewhat similar. In fact, in many ways it's very similar to what goes on inside a computer. And the way that computers work is they work on algorithms, if-then statements. If this, then this. And so an algorithm, as you can see, is a learned set of rules that always leads to a correct solution of a problem. So again, once we begin to develop computers and develop algorithms for computers, we begin to understand more about our own thinking and our own ability to use those thoughts productively. For test purposes, leave out the term heuristic. Heuristic is sort of a simplified way of solving problems. Leave out insight. I'll just mention it, but leave it out for test purposes. Insight is where we come to a certain sudden realization of how to solve a problem. Fixation, leave that out for test purposes. But fixation is when we come up with the wrong solution and we continue to use that wrong solution, but leave those out. Intelligence, we're going to talk about intelligence quotient, so leave out the term intelligence. We're going to focus on intelligence quotient. Not only is a definition, but we've got a question that deals with the intelligence quotient. You can see on page 307 the term intelligence quotient. An index of intelligence defined as a person's mental age divided by his or her chronological age multiplied by 100. Now that seems so simple to define. Yeah, that's an intelligence quotient. But there are so many concerns. And I hope those of you who are especially those of you who are going into education will really appreciate, the concerns and the consequences of trying to sort of reduce a person's intelligence to a number. Now, we're not going to talk about multiple intelligences, it's talked about in this particular chapter, but this is one of the concerns that many people have within the education community that we sort of tap into, where we test one type of intelligence, and many individuals have a different type of intelligence. For instance, a person may have musical intelligence, but not fare very well on a standardized IQ test. A person may have mechanical intelligence, but not fare very well on a standardized IQ test. So even though I want you to know the traditional formula that we use to come up with IQ, we're going to look at that as a separate question. Just recognize that there are so many issues involved with this question of how do we determine a person's intelligence quotient? How do we reduce that person's intelligence to a number? But for test purposes, just be aware of the definition here on 307. For test purposes, just leave out the term deviation IQ. Let me just quickly tell you, deviation IQ comes more into play today where we put people's intelligence scores on computer databases, and then we compare one person's score to the average of the scores of people who have taken it. So remember that term standard deviation that we looked at when we looked at the section on statistics, how far a score falls from the mean of a group of scores. This is what we're concerned about with deviation. And so deviation IQ has to do with how far a person's score falls from other people's scores. But for test purposes, leave that out. So again, we've left out mechanical solution, understanding, heuristic, insight, fixation, intelligence, and now we're leaving out deviation IQ. Artificial intelligence. I would like for you to know the term, because the term really suggests some things that are really exciting that are happening in terms of cognition, thinking, and intelligence. You can see any artificial system, often a computer program that is capable of human-like problem solving or intelligent responding. Obviously, we're relying more and more on computers. There are now smart televisions that bring all kinds of problem-solving capabilities into our homes. Obviously, our smartphones, our computers have been doing this for us for a long time. Some of you are going into the medical community. There are rural hospitals. I think I mentioned on a couple of occasions that at one time I was on the Spartanburg Area Mental Health Board, and one of the problems, the challenges for rural communities is that there are not enough psychiatrists. So we worked through the Duke Endowment to get some funds that would allow what's called expert systems, that a local hospital in a rural community could have access to the resources of a psychiatry department at a larger hospital through a computerized sort of network connection. And so there are a lot of opportunities for what's referred to as artificial intelligence. When we use computers and computer-like devices to enhance our intelligence. Now, some people feel that in the future, so we may walk around with jacks where we can sort of jack into sort of computer networks. There was a movie done a few years ago, Johnny Mnemonic, I think was the name of the movie, where a person actually had storage capability from computers in his brain. So this is an exciting area of artificial intelligence that inevitably will affect us more and more in the future. Okay, let's go to the questions. Now again, this is not my favorite way of teaching. As you know from your classroom experience, I like interactive. I wish you were here so that I can call on you to sort of give your interpretation of these concepts, and then we would discuss them and come to sort of a conclusion the way that I would like for you to approach them on the test. But this is going to be cut to the chase. I'm just going to sort of present to you, what I would like, the way I would like for you to interpret what the authors have sort of indicated here in the book, and hopefully, I'll do it in such a way that it will be easy for you to remember for test purposes. Now, obviously, when we get back into class after your spring break, one of the first things that I'll say is that we need to go back and look at any of those concepts that I covered in the video, because there's no one here, so no one can raise their hand and ask for clarification. So when we get back, please, if there are any questions, how I would want you to approach this for test purposes, please, make a note so that we can address that. But the term internal representation, actually, there's a definition here at the beginning of the book. So let's go back and point out where that definition is. It's on page 284. And you can see that they refer to it as internal representation. And what they're talking about is a mental expression. Now, what does that mean? A a mental expression. Before we think about the world, and remember this term cognition, we're talking about thinking. Before we think about the world and everything in the world that we could possibly think about, we have to have a way of taking that in. And that's what we mean by a mental representation. Now, to give a very simple sort of illustration of what we mean by mental representation, and this is where I have in parentheses the classroom demonstration. Obviously, I'm holding up something here. If you were in class, I would select somebody. I would ask them, remember, sort of take a look at what I'm holding up here. And then I would put it back here behind the podium. And then I would say, tell me and tell the class, what it was that I held up. This is what we refer to as a mental representation, or a mental expression, where you take what is in the external world and you put it into a form that you can store inside your nervous system, and we can sort of generally say inside our head, inside our brain. So this is what we mean by mental representation, taking the world that is out there and converting it into a form that we can store in our brains so that we can then think about it. This is what we mean by mental representation. Now, obviously, this is critical. If we can't take the external world and put it in here, then we don't have anything to think about. And this is why, this sort of exercise is more challenging for a toddler who doesn't have the ability yet to mentally represent the way an adult does. You show this to a toddler up to a certain age, they would be fascinated by it because it makes sound, and it's sort of glittery. The keys are sort of glittery. But if you put it back here where they couldn't see it, then out of sight, out of mind. And because of that, we don't think that toddlers do a lot of thinking. They may process visual images, as we talked about before, and we don't think that animals do a lot of thinking because they don't have the same capability of representation, of taking that external world and putting it into a form that we can use it in terms of our mental system, our brains. Now, this leads to our discussion of mental images. One of the simplest ways to do this, and it's not a very effective way in many ways, is what's called mental images. Literally, if you ask me to close my eyes, which I'm doing now, and get a visual image of my dog, I can do that, and I can get a visual image of my car. I can get a visual image of the house that I live in. So this is one of the ways that we are able to internalize the external world in terms of mental image. And it's a very effective way of doing it. So, in parentheses where I said, describe a situation used where you use mental imagery to represent the world. I'm doing it. I'm telling you, I can close my eyes and I can see my dog. I can close my eyes, I can see my house. So I am thinking about, I am mentally processing the information about my dog and my house by recreating an image, a visual image. Now, that's wonderful, but what's the problem with that? It's not very economical. It's just like if you would send on a computer, if you would send a text message, or if you would send one of your friends an attachment with a picture, which one would use up more of the sort of bandwidth to send that message? Obviously, the picture would. It would take a lot more of the resources of the computer network to transmit the picture. So it's the same with our mental thinking, that the visual images use up a lot of the resources. So this is why humans have developed this wonderful ability to understand the world conceptually. And we've already looked at the definition of a concept, but let's look at this again. And you can see that the definition of a concept is on page 285. It's a generalized idea representing a category of related objects or events. So we can process, we can think about the world conceptually. For instance, and we use symbols to sort of represent these concepts. So for instance, I can close my eyes and see my dog, but if I want to think about dogs in general, if I want you to think about dogs in general, I can put 3 letters up there, D-O-G. I haven't put a dog on the board. There's no dog on the board. This is not going to bark. It doesn't have fur, but this is a concept. This is a concept that sort of categorizes a group of animals that have certain characteristics. So this is what we mean by a concept. And we don't step back and think about how wonderful this is. Think about the world of communication. Think about the world of thinking. If we weren't able to, conceptualize the world, if we had to, sort of play charades, if we had to sort of communicate only using images. So the ability to conceptualize has allowed us to put our intelligence in books and to pass that intelligence from one generation to the next. And now we're doing it in terms of computers. And it's exploding, our ability to sort of conceptualize the world and to deal with the world in terms of concepts. Now, obviously, this is one of the main things that you learn in school. You learn concepts. In the last chapter, the test that, I'm talking to you on Tuesday before the test on Thursday, but when, we conceptualize what classical and operant conditioning are. So, we're able to capture what a process is through using concepts and using words to label those concepts so that we can think about them, we can analyze them, and we can use them. Now, there are different types of concepts, and you can see, and these are listed for you on page 287. The type of concept that we use most often is what's called a conceptual, it is called a conjunctive concept. So in a conjunctive concept, and you can see the definition here, a class of objects that have 2 or more features in common. So that if I'm trying to conceptualize a dog, I can say 4 legs, 1 tail, and then I'm just going to put down here barks. Okay? So, if I put 4 legs, 1 tail, you probably could narrow it down to a dog. But when I add, so I put 4 legs plus 1 tail plus barks. This is what we mean by a conjunctive concept. When you form a concept, for test purposes, I'd like for you to know that a conjunctive concept, and you can see here in the definition that has 2 or more features that we sort of look at in forming the concept. This is an additive concept. This is when we take those features or characteristics and we add those characteristics together so that eventually, after we add enough characteristics, we're able to formulate the concept. So that what do you do? What did you do here? I said 4 legs, 1 tail. Okay, that could have been a horse. That could have been, any number of animals. But then when I add 1 more characteristic, barks, then this pretty much narrows it down to the concept of the dog. So a conjunctive concept is when we add these features or these characteristics together that then allow us to sort of formulate this particular concept. Now, this is not the only way that we form concepts. There's what's called relational concepps. And relational concepts, and in the book, I want you to go a little bit beyond the definition in the book because this is sort of a circular definition. Remember, I don't want you to use circular definitions. A concept defined by the relationship between features of an object or between the objects and its surroundings. Now, don't use, relationship to define a relational concept. What do I mean? A relational concept is formed when we sort of compare or contrast one thing to another. For instance, if we were in class here, I would ask someone, if they have, a brother, Quay told me today in class that I would remember him, so I'm going to use Quay. Okay, and before we came in, Quay told me that he was riding his brother's motorcycle. He didn't tell me his brother's name, but I know Quay has a brother. Quay, I'm sure, has been conceptualized at times, and I'm just going to give Quay's brother a name. Apologies to Quay's brother, but I'm going to call him Bob. Okay, so Quay, I'm sure, if Quay's brother's name was Bob, had been referred to sometimes too as Bob's brother. So we conceptualize Quay in relationship to his brother. Sometimes another way to form a relational concept, for instance, I'm trying to think of a person in the class. Well, I'm just thinking of Logan. Obviously I'm 6'4". Logan, apologies Logan if this is not correct, but I'd say probably 5'3", 5'4". But obviously there's a height difference. So if a person just saw a silhouette of Logan and me, then they could say, well, the tall person is probably Dr. Buchanan, the shorter person is Logan. If they knew that one person was me and the other person was Logan. So why would this be a relational concept? You would be identifying, you would be conceptualizing one person as being distinct from the other person by the fact that one person is taller than the other. And we do this all the time. You get your grades back on the test. Hopefully you won't make this generalization, but you could say, well, that person did better than the other person, so that person's smarter than the other person. So when we compare and contrast in forming our concepts, this is what's called a relational concept. Now, a disjunctive concept can be rather confusing. Now, the book gives a really good illustration of a disjunctive concept. Let's look at the definition again. A concept defined by the presence of at least one of several possible features. Now, the book gives us an example, baseball. The concept of a strike in baseball. Okay, what do we mean? Now, when we refer to a strike in baseball, why is that a disjunctive concept? Now, you would say, okay, a strike. You take a little kid to a ball game and the kid say, well, what's a strike? Never been to a baseball game. You say, well, it's when the batter stands up there, swings and misses, and the umpire calls a strike. You're trying to simplify it for him. So, the batter stands up there, pitcher pitches, the batter doesn't move. And so the umpire goes, strike one. And so the kid looks at you and says, well, I thought you said the batter had to swing and miss. Well, let's look at this kid. A strike can be either if the batter swings and misses, or if it is, the ball goes over the plate. So a strike can either be a swing and a miss, or if the ball, goes over the plate in the strike zone. So it's either or. Now the batter stands there again, pitcher pitches, batter swings, hits the ball, but the ball goes that way. The umpire says strike two. The kid goes, wait a minute, you told me that a strike was either if the batter swings and misses, or if the ball goes over the plate in the strike zone. The batter hit the ball, and the umpire calls strike. Well, it can be, it's an either-or concept. Something can be conceptualized as either this way or this way. For instance, if someone came to me and said, well, yeah, I have this pain here in my hip. You're a doctor, help me. Well, a doctor can be either a college professor or a medical doctor. So either or. And this can be sometimes confusing, that we use the same symbols or we use the same labels for different concepts. And so when a number of different features can define the same concept, we refer to that as a disjunctive concept. Okay, now we said that we leave out number 4. Let's talk about two processes that we use in thinking called inductive thought and deductive thought. And you can see the definitions. So let me turn to the definitions here. We'll go over that first, and then we'll we'll talk about inductive and deductive thought. On 297, you'll see inductive thought thinking, in which a general rule or principle is gathered from a series of specific examples. For instance, inferring the laws of gravity by observing falling objects. So for test purposes, I'd like for you to think in terms of inductive thinking. When we think inductively, and scientists usually use at first inductive sort of processes, is when you start with something specific. You start with a specific observation, or you start with specific facts, and from those you come to a general conclusion. So you start with a specific observation, specific information, or specific facts, and then you come to a general conclusion. So that you would say you see somebody sort of driving recklessly, you observe them, you specifically see them driving recklessly, you come to a general conclusion. I bet they're going to have a wreck. Okay? So you come to a general conclusion about the specific observation. That's what we refer to as inductive thinking. Now, the lines are sort of blurry in between. Sometimes there's a question whether it's inductive or deductive. But usually when we think of deductive reasoning, and you can look at this on page 299, we're thinking about thought that applies a general set of rules to specific thinking. So in deductive thinking, we're starting out with some general information or some general rules, and from that general information or general rules, then we derive something specific. We come to more of a specific conclusion. Now, if you would, this is where I'd like for you to get out the little sheet that I gave you on inductive and deductive thought that I gave you in class. And it was actually a group activity. Let me find a blank sheet here to show you. But it was in the form of a group activity. If you'll remember, this sheet right here. But obviously, because of the nature of the way I'm presenting this information, it's not going to be in a group activity. But for test purposes, in addition to asking you to sort of let me know that you know the difference, distinguish between inductive and deductive thinking, modify that second part of the question. Please modify. We're not going to have time for the group activity. But modify that second part. Instead of making a statement, I'm actually going to give you a statement like on this list here and ask you to identify it either as inductive or deductive thinking. Now let's go through the list, and I wish we'd had time to do it as a group activity. But let's look at the first one. If it's raining, then the ground is wet. It is raining, therefore the ground is wet. So you're given some general information. You're given some general knowledge about what the situation is. If it is raining, you're giving some general sort of information. And then the fact that it's raining suggests that because you're given this general information that when it's raining the ground gets wet, you notice it's raining, so you then come to a specific conclusion that probably the ground is wet. So that one would be deductive. The next one, John's wife observes he has lipstick on his collar. She concludes he must be cheating on her. So the first part was a specific observation, and so from the specific observation, John's wife came to a general conclusion, so we would say that one is inductive. The next one, it's snowing today. We probably will not have to go to school. So again, it starts out with a specific observation, and from that specific observation, then there is a general conclusion. The next one, all polar bears are white. The bear in the zoo is a polar bear. It must be white. This one is deductive because you're given some general information. You're given the information at first that all polar bears are white. So you're given that general information. And then that allows you then to come to a specific conclusion that this particular polar bear must be white. The next one, the dog growled, it may bite me. You made a specific observation. you came to a general conclusion. This one is inductive. And then in the next one, number 6, in a democracy, people vote. I live in a democracy, so I can vote. So you're given some general information about what happens in a democracy. The people in a democracy can vote, and that allows you then to come to a specific conclusion about your ability to vote. So that one would be deductive. So again, for test purposes, what I'd like for you to do is to be able to describe sort of a definition, if you will, what we mean by inductive and deductive thought, and then also to be able to identify some statements that would be classified as inductive and some that would be classified as deductive. Okay, we said we'd leave out number 6. Let's move to number 7. Here is one that is rather troubling for me because, as I said, how do you reduce a person's intelligence to a number? But what I'd like for you to do is know the formula, and you can see the formula on page, that formula is on page 306. Now, this formula is now sort of outdated in a way since we use computers so much. Nobody's writing out an actual formula, doing it by hand. But the principle behind this formula is still there in terms of our thinking about intelligence quotient. But the traditional formula, I'd like for you to know what the components of the traditional formula were. We would use a formula that MA, and I'd like for you to know what these are, divided by CA times 100 equals intelligence quotient. So what do we mean? Middle age. Well, first of all, let's start with chronological age because this is the simplest one. What we mean by chronological age is how old a person is in terms of years. So if we're giving this test, this IQ test to a 10-year-old, we would say that person's chronological age